Good morning, everyone. Today I'm going to present this paper. The title is Efficient Perovskite Solar Cells Achieved Using a 2-Mesocyte ethanol activity. And this paper was published in ACS Applied Energy Material in 2021. And the main topic is about perovskite solar cell, also called PSCS. And in this study, and the another use an activity called 2-Mesocyte ethanol or 2-NE to improve the quality of the perovskite field. And the main idea is simple. And if the field becomes better, the solar cell can also become better. So in the presentation, I will explain the background, the experimental methods, and the film properties, and the device performance, and the film conclusion, and the final conclusion. So first, let's talk about why film quality is important. And in perovskite solar cells, the perovskite layer is additive layer and it absorbs light and generate charge. And if the film quality is poor, and there will be many green boundaries and pinholes. And green boundaries are the space between small crystals, and pinholes are small holes in the film. And these defects can create trap states. And trap states can catch charge and cause recombination. So this makes electrons and holes meet again and disappear before they are collect. And as a result, the device has lower voltage and lower field factory and lower efficiency, and also monostruts and oxygen can enter the field source these devastated areas. So this makes the device less stable, and so a high quality film should be dense, smooth, and have large grains. And the strategy of this paper is to use 2-NE as a solvent activity, and the normal precursor solution contain DNF and DNSO. So in this work, part of DNF is replaced by 2-NE, and the other one to control the intermediate field. And the intermediate field is from before the final perovskite film. And it is very important because it affects the final crystal growth. And the half-life is that 2-NE can change two things. And first, it can change the morphology of the intermediate fields. And second, it can change the composition, especially the amounts of DNSO left in the fields. So if the intermediate field is better, the final NaPbL3 perovskite layer can have larger grain and fewer defects. And finally, the solar cells should have higher efficiency and better stability. And this slide shows the device structure and the preparation process. And the device structure is FTO, SNO2, NaPbL3, and spiral-ONE pad, and AgFTO. FTO is the transparent electrode, and SNO2 is the electron transport layer, and NaPbL3 is the perovskite activity layer, and spiral-ONE TAD is the whole transport layer, and Ag is the metal electrodes. And the other use one-step anti-solvent method to prepare the perovskite film. And they add different amounts of 2-NE and 0, 10, 20, and 30 volt process. And the ratio of DNF plus 2-NE to DNSO was fixed at 4:1. And after spin coating, and they drop an anti-solvent mixture onto the film. Then the film was annealed at 100 degrees Celsius for 10 minutes. And the cross section SEM image show the show that the device layer are cleaner and well format. And this side shows SEN and AFN image of the Perovskite fields. So for the field without 2NE, the green are small and the green boundaries are more obvious. And after adding 2NE, the green size become larger. And this makes the field has fewer green boundaries, and the best condition is 20-volt process 2NE at these conditions. And the average green size is about 400 nanometer. And the surface is also smoother with a roughness of about 5.16 nanometers. And however, when the amount of 2NE increased to 30-volt process, and the surface become more bluier and rulers. So too much 2NE is not good. From this results, we can say that 2NE can improve the morphology of the Perovskite field. But the almost must be amazing.
Next, the also use XRD to study the crystalline crystallinity of the fins. XRD can tell us about the crystal structure of the material. The main peaks are at 14.1 degrees and 28.5 degrees and 31.9 degrees. These peaks correspond to the perovskite crystal planes. The important point is that adding 2NE does not create a new phase, so 2NE does not change the physical perovskite structure. However, the 20 value percent 2NE sample shows the strongest and the sharpest peaks. Stronger and the sharper peaks means better crystallinity. This result agree with the SEN and FN result. So 20 value percent 2NE gives large grains, smoother surface, and a better crystal quality. Now let's look at the mechanic. Also used FTR to study the interact between solvent in the intermediate feed. DNSO can study inside the fin. Too much residual DSO may cause pinholes during annealing. The FTR result shows that after adding 2NE, the signal of NH and the SO change. Also, the ratio of SO to NH decreases. This means the amount of DSO in the intermediate feed becomes lower. Why does this happen? The also suggests that 2NE can interact with DNSO for hydrogen bonding. Because of this interaction, DNSO becomes easier to remove during the anti-solvent process. With this natural DNSO, the fin can avoid pinholes and form larger grains. So 2NE improves the fin not only by changing morphology, but also by changing the composition of the intermediate filling. This slide shows PL and TRPL results. PL means photoluminescence. It tells us about the combination in the fin, the 20 value percent 2NE fins has the highest PL intensity. Higher PL intensity means lower non-radiative. The combination in sample words, fewer charges are lost, so defects. TRPL gives more information about carrier lifetime. For the control fin, the lifetime has shorter for the 20 value percent 2NE fin has the first lifetime is 38.9 nanosecond and the third lifetime is 329.2 nanoseconds. Larger lifetime means the charge can stay longer before recombination. This suggests that the 2NE fin has fewer defects and a better crystal quality, so the optical results support the idea that 2NE reduce trap state in the perovskite fins. Now, let's discuss the device performance. The best device is made with 20 value percent 2NE. For the reference device, the current voltage is 1080 millivolts. The current density is 21.6 milliamperes per square centimeter. The field factor is 73.2%. The efficiency is 17.1% for the 20% to any device. The voltage increased to 1102 millivolts. The current density increased to 22.5 milliamperes per square centimeter. The field effect increased to 77.8%. The efficiency decreased 19.3%, so the efficiency increased from 70.1% to 19.3%. The hysteresis index also decreased from 0.111 to 0.077. This means the device behavior becomes more stable during measurement. The average efficiency is also over 18.5%, showing better repeatability. Overall, 2 and E improve voltage, current, field effect, and the efficiency.